Hello, folks. We are going to do our algebra semester final. I've already downloaded it. This is the practice, just for the record. This is not the final, but it will be soon. I didn't spell practice right. Oh, well. And we are going to solve it. I already downloaded it. It's already in Kami. I'm going to go fast because, honestly, I got to get this done before school starts. So here we go. This particular function at the beginning is called an explicit formula for a function. Explicit in math means give me an x, I'll figure out y. So it changes an x into a y or a y into an x. You give me one variable, I find you the other one. In this particular case, we don't have x's and y's, though we have g of t, whatever that is, right? Well, that's a function where t is like x. T is the number, the variable, my whatchamacallit variable, I'm sorry. My independent variable. And g of t, this thing right here, the full thing is like my y. So it's like y equals 3t minus 2t plus 1. Okay, so let's figure out what that makes. I'm going to zoom in a tiny bit because I might as well, and then we'll be able to see better. And I can type in things in a smaller font, and you'll be able to see it. Okay, so what we have is g of 3. That means that I changed t to 3. So let's change t to 3 and see what that makes. We're going to end up with 3 times 3, which used to be t, minus 2 times 3, which used to be t, plus 1. That's the trick. All I did was change the t's to 3's, because that right there tells me I'm changing t to 3. All right, we will figure out what that makes. 3 times 3 is 9. 2 times 3 is 6. And 1 is 1. There we are. Every time I try to move things on here, I accidentally push the button and then scroll down for a screen or whatever. Okay, 9 minus 6 is 3. 3 plus 1 is 4. G of 3 equals 4. That's my answer. Okay. Because I'm in a hurry, I'm just going to tell you the answers and make sure that you can get the answers to the next ones. Show all of this work. Fill all of this out. Do it over and over. But all I have to do is plug in a 4 here, and I'm going to get g of 4 equals 5. And I'm going to get g of 5 equals 6. But you should see the same work for each of these. The only difference is I plug in a different number. This one I have to plug in, turn t to a 4. And here I turn t to a 6. So I could write really quickly t equals 4 here. Oops, not minus 4. Equals 4. And t equals 5 here. And when you plug it in, you multiply 4 times 3 and 2 times 4, and you subtract them and you add 1, you get 5, I promise. Okay, so that's the way it's done. All right, I hope that I gave it enough. And I'm just boxing my answers so it's very clear. I hope that that's enough information. This should not be a hard problem. It's kind of a gimme problem. You definitely need to know how to plug things in. Okay, that's the first one. The second one we have is called a recursive formula. In a recursive formula, it's not you give me x, I find y. It is give me the first number and I will find the next one. All right, so this one, it doesn't find x from y. It's not you just plug in a number and you figure out the answer. You have to know the previous number that happened. So like this one, if I'd have to know that 4 happened, and that would tell me how to find the next number, 5, and that would tell me how to find the next number, 6. Okay, so this one, you notice the numbers are getting 1 bigger each time. That's what recursive formulas tell me. what I'm doing to get the next number in a row. Okay, so we start out with h of 1. Well, the cool thing about this particular formula is it tells me how to find the next number, and then it tells me the first number right here. So this is, oops, this is the information how to find the next number, and this is the first number. Okay, that's what's going on in here. There are two parts to the formula. It tells me how to find the next number first, and it tells me where to start. So if it tells me where to start, it says the first number is 3. So guess what? H of 1 is 3. It says it over here. So h of 1 is 3. That's all there is to it. No math to do. Okay, so here's where things get interesting, though. So if I want to find the next number, I'm going to h of 2. I'm going to turn the n's to 2's just like I did before. But you'll find out it doesn't really tell me how to find it. So what we've got is h of 2 equals 3 h of 2 minus 1 minus 5. Now notice this h of 2 minus 1, those are in parentheses, so I'm going to subtract them. I'm going to get h of 2 equals 3 times h of 1 minus 5. Now remember, this h of something, this is function notation. H is not a number. Just like g was not a number. G of 5, that's just talking about like my function. I'm just going to call it the letter h. It has the variable n in it. So right here we have, this is the second number, that's what we're trying to find, equals 3 times the first number. H of 1 means the first number. We know what that is. It's right here. H of 1 is just 3. This right here is just 3. That's the trick. That's the trick. That's how recursive formulas work. To find the next number, h of 2, I really have to take 3 times the first number, which was 3, minus 5. So this right here, goes like that. Okay, that's the trick. So now I know that h of 2, I'm going to actually start another row over here. H of 2 equals 6. 3 times 3 is 9 minus 5. H of 2 equals 4. I accidentally typed 4 in there because I was thinking of 9 minus 5. There. That's the answer. Let me really quickly change this to red. Go back to letters and turn my letters back to black. There. Okay, so now I know h of 2 is 4. Now notice this is always going to be 1 less. So I actually know how it's going to work, but let's just do the whole thing all over again. So I'm going to do a lot of typing. Now we're finding h of 3. Right? H of 3 equals, I'm not going to write it this way because it just said h of 2. So I'm going to leave the h of 2. I'm not going to write it twice, basically. So I'm just going to write h of 3 equals 3 times h of 3 minus 1 minus 5. That's actually 3 times h of 2 minus 5. I know what h of 2 was because we just figured that out, right? H of 2 is 4. So I'm going to change h of 2 to a 4 equals 3 times 4 minus 5. And I go back up here. H of 3 equals 12 minus 5. I did it again. I accidentally typed 4 instead of 5. 12 minus 5 is 7. H of 3 equals 7. And I did it. Notice in recursive formulas, actually, no, I'll do it the same way as we did before. I'll make this go down here. This is h of 2, which is 4. Okay, to find each number, you plug in the last number that you got. You don't just plug in a number for n and you get an answer. That's different. The way we can tell that is because we end up with n minus 1 right here. So you end up with talking about the previous number when they have that. It changes the h of 2 to h of 1, the h of 3 to an h of 2. And then you can just know that you're talking about a certain number. Okay, that's all there. Okay, the steps for doing this. 1, cross multiply. If you have two fractions that are equal, cross multiply every time. 2, divide to isolate x for the variable. Okay. If you see a proportion to equal fractions, these are the steps you're going to do every time. Okay, so I'm going to do that really fast. Are we ready? I'm going to cross multiply. 5 times x, 12 times 15. That's what I should get. 5 times x, 5x. Let's move it in a sec. Equals 12 times 15. I'm okay if you use a calculator for multiplication like this. I know that some people are not big fans of that. Perfectly okay. I'm going to do it without a calculator. I'm going to get 180. Okay, 5x equals 180. Okay, now is the part where I have to, so that was the first step. And now we're going to divide right here. Change this to black. There's the left side. There's the right side. Back to text. Enter. I'm going to divide by 5 over here. Divide by 5 over here. Fives are going to cancel out like this. Oops. I don't want to change that to red. I want to write in red. Fives are going to cancel out like that. And I'm going to end up with x equals 180 divided by 5. 180 divided by 5 is, well, let's see, that's going to be a fun one. Well, it's going to be 3 times 12, which is 36. All right, there are ways that I do this faster, but I don't really want to muddy the water here, so we'll call it good. Notice I'm circling my answers. First answer was 4, second answer was 5. You know, in fact, I will erase these. I like the way it looks. 5 and 6. There. Okay. So we're here. We solved this one. Okay, let's do the same steps. Notice I cross multiply, I divide. This one right here, cross multiply. I'm going to get 12 times x equals 5 times 15. All right. 5 times 15. Oh gosh, it's 50. It's 80. No, it's 50, 75. 12. Well, I'm going to actually, 12x equals 75. Now I got to get rid of the 12, so the x is alone. So I divide both sides by 12. That side by 12. This side by 12. Back to writing. Enter 12. with, this crosses out like so, and we get 75 divided by 12. X equals 75 divided by 12. I would accept this almost, although I would prefer that you simplify it. We notice that what goes into both of those, 3 does. If I divide them both by 3, I get equals 25 divided by 4. Better. And if I know how to divide 25 by 4, or I could divide 25 by 4 and I'd get 7.5. No. 12.5. 6.25. X equals 6.25. You divide it with a calculator. Like I said, you're allowed to use a calculator for these types of things if you're feeling like you want to just make sure that you did your math right. That's what they're for. Okay, so I prefer the simplified fraction, or you can turn it to a decimal. Some decimals are not very pretty. Notice, it's not simplified like I turned it to a mixed number. I don't turn anything to mixed numbers from now on in math. We just don't do that. All right, so now I'm going to do the same thing, cross multiply. All of these are the same. This one is slightly different because it has an x plus 1. What do I do with that? Well, here's an important thing to notice. When I have an x plus 1 on the bottom of a fraction, it's actually got parentheses. You have to make sure that it has parentheses when you cross multiply. 15, you end up with something like that. Multiplied 8 times 15, and x plus 1 times 28. Now, here's the weird thing. I can, well, let's do distribute here. We'll distribute, because you've learned how to do that before, so I might as well do it. I'm going to distribute the 28 and multiply it by the 1 and the x. If I don't remember their parentheses, then I never get that. Just remember, if you ever cross multiply, if there are multiple things on the top or bottom of a fraction, then what happens is you have to remember that that's in parentheses. The bracket here is parentheses. It's just that it's not. It's implied, but it's not actually written out. That's something you can always remember for the rest of math, for the rest of time, that's true. So we have 28x plus 28. So this one is slightly different. 8 times 15 is 80 plus 40 is 120. Okay, so now we've got this. This is not the same as the other ones because it has a plus and a multiplication with the x. Remember, if we're ever solving for x, and we're going to do this a lot, you're going to subtract first and then divide. So I'm going to subtract 28 from both sides. Minus 28. Minus 28. That's nice and pretty. So what that's going to do is, nope, I don't want that to be red. I want this to be red. That's going to get rid of this. So I'll end up with 28x equals 120 minus 28 is 92. Now I have to divide by now I have to divide to get rid of the 28. I line up all my equal signs. It makes things easier to read for everyone. That's why we do it. It's easy to make mistakes if you don't. So now I want to get rid of this 28. Let's do it. Here's the 20. No, it's fine. Here we are, dividing by 28. Boom, 28. Boom, 28. These cancel out as well. Boom, canceled out. So I'm left with x equals why is that big? wants to change size somehow. That's fine right now. Equals 22 divided by 28. Weird. All right, so 92 divided by 28. I can simplify that a little bit. They're both positive. Goes into both of those. Well, we're going to take half of each of them. That's going to make 45, 46, 46 divided by 14. We're going to take half of that. X equals 23 divided by 7. All right, I prefer that. I will tell you, if you put it in a calculator, you're going to have to write a lot of decimals. Okay, I'll probably accept it, give you credit if you use a calculator. But if you get a whole bunch of decimal places, it's easier to leave it as a fraction. That's what we prefer in math, so I just leave it as a fraction. All right, last one, cross multiply. I end up with 3x times 24 equals 8 times 36. Okay, this is a big one. There are lots of numbers. If I wanted to, I could actually save time and I could simplify the one on the right here till I had smaller numbers. So it's 36 and 24. I can notice that 12 goes into both of them. So that's really 3 over 2. I could rewrite this as 3, and this is 2. 3 and 2 here. And it would work just fine. Okay, you could do that beforehand because it's the same fraction. 36 over 24 is the same as 3 over 2. But I'm not going to, because that's another step that you don't need to think about, right? Nobody wants to think about another step. Okay, this one's a little weird because I have a 2. Oh, that's not a 2, that's a 3. A 3 and a 24. Now it's 3 times x times 24. Now the truth of the matter is, according to the commutative property, if I have 2 times 3 times 4, that's the same as 3 times 4 times 2. It doesn't matter what order I multiply in as long as they're all just multiplying. They're all the same. 2 times 4 times 3. Oops. It doesn't matter. All of the different ways that I could arrange it, it still makes the same number. So I'm going to rearrange the order that I multiply this in. I'm going to do 3 times 24 and leave the x out. So I'll have 3 times 24 times x. Well, 3 times 24 is 60, 72. Really, this is 72 times x. And then we end up with 8 times 36. That's a big number. We're just going to not worry about that right now. Well, no, we will. 8 times 36. Let's see. 8 times 3 is 224, so that's 240. 8 times 6 is 48. So 48 plus 240 is 288. I believe. I hope that I get this right. And then we're going to divide by 72 like we did before. So these just have little steps in the middle that make it like a little bit different, but they're not particularly complicated problems. The steps are still basically the same. I cross multiply, divide. Okay. Back to this. 72 and 72. And the 72 is going to go away on the left side, leaving us with x. Now we're going to go more deeply into why you're allowed to do this stuff in the next class, I believe, or in the next chapter or two. We're going to talk about, well, I guess we're going to graph a lot first, but 288 divided by 72. Let's see, that's the same as, divide some things. Let's see, 288, half of that is 144. Half of 72 is 36. All right, we're going to do a half again. 50 plus 22 is 72. Half of 36 is 15 plus 3 is 18. Still not there. Okay, 72 divided by 18. Let's see. No, we're going to do half of that. So we're going to end up with 36 and 9. Hey, what's 36 divided by 9? That's 4. X is 4. So if I plug a 4 in, I'll get 12 here. 12 divided by 8 is the same as 36 divided by 24. You'll find that that's true. Okay, so that is how we do these. I hope that makes some sense to you. I know this is a little bit more mathy. We're trying to move in that direction. Okay, so this one. Here's the thing you need to know. This is direct variation. We had a section on that in the book. Direct variation, we always use this formula. Step 1, use formula to find K. Use formula /K to find X or Y. That's the steps for direct variation, actually, I'll say. Oh, that was good the way it was. I need to go that way. There. In direct variation. This is the 2 steps. Use the formula to find K. Use the formula and K. I'll say and K to find X or Y. Okay, so let's do that. Let's use our formula. We have Y equals KX. Okay, KX means multiplying K times X. All right, and they tell us that X is 3 and Y is 15. Okay, let's make X be 3 and Y be 15 then. 15 would be Y. There, and I did it. There. All right, so we've got X is 3 and Y is 15. Let me really quickly go like this. X is 3, Y is 15. That's what we did. And that's going to tell us what K is. All right, so now I'm going to divide by 3, which means K. Well, what times 3 makes 15? 5. K has to be 5. In other words, X is always 5 times, Y is always 5 times as big as X. Okay, so you don't have to know that that's what K stands for, but that is what it stands for. We're going to start, now we're going to do step number 2. Now that I know that K is 5, I'm going to use that to figure out the new number. So I have Y equals AX. And I know that K is 5. Y equals 5X. I also know that we're going to try to find Y based on that fact that X is 5 as well. We want X to be 5. Okay, so let's make X be 5. Y equals 5, which is K, times 5, which is X. Well, then that means Y equals 25. That's the steps involved, okay? So let me really quickly, we're going to circle this one in green. So I'll box it. Box it in green. Very good. And then I'll make a line in green. This is step 1. Now I'm going to box the other one in pink. And I'll make a line to it as well. That's step 2. All right, that's the 2 steps. That's what we're doing here. All right, and just as a reminder, we're plugging in this guy right here. We're plugging in this guy right there. Those are the steps we do. Hopefully that makes sense. All right, this does take a lot longer when you're typing, doesn't it? Okay. I'm going to do the same thing again. Y equals kx. Y is 21 equals k times 6. In other words, 6 times something makes 21. Well, that's going to be a ugly number, kind of, isn't it? All right, well, let's figure out what that is. I'm going to divide both sides by 6, like I did in the past. K equals 21 divided by 6. What do I do? Okay, if I want to figure out what that is, it's going to be um, 21 divided by 6 is actually 7 divided by 2, or 4.5. No, 3.5. Okay, so now I know that k is 3.5. 3.5 times 6 makes 21. Yep, that works. Okay, so now I'm going to use that to find the next one. Y equals kx. K is 3.5, so this is really y equals 3.5x. And x is 10. Y equals 3.5 times 10. That means y equals 35. Boom, that's it. Well, I never remembered to circle the answer here. There, we got our answer. Okay, this is similar. This is also directly proportional. Direct variation. So I'm going to solve this the same way. I'm going to use y equals kx. Okay, now let's figure out how to solve it. What are my numbers? Well, we're talking about Jane finishing a puzzle. The more puzzle pieces there are, the longer it takes to finish the puzzle. That makes sense so far. Okay, so what's going on here? It takes her 1,000 pieces, takes 8 hours. Okay, of work. We're going to work with that. Those are my 2 variables. So based on how many hours it takes her, we can figure out how many puzzle pieces it'll make. Or based on the number of puzzle pieces, we can figure out how many hours it will take. Honestly, it doesn't matter which one I make x and which one I make y. I'm going to make this be y and this be x. Oops. Okay, so what that means is when I get back down here, which is black now, I'm going to say that y is 1,000 equals k times 8. Okay, so now I'm going to divide both sides by 8. There. Figure out what 1,000 divided by 8 is. I believe it's 125, but I'll double check. 1,000 divided by 8. Let's do it. 1,000 divided by 8. 125. Very good. Okay. So 125 equals K. Okay, so I know K equals 125 now. What does that mean? It takes her about an hour for every 125 pieces in the puzzle. That's what we're saying. Okay, so what does that mean? Well, now we have a puzzle that's 51,300 pieces. Okay, so I need to solve that one. How long will it take her to do that? Well, I made pieces be y. So I'm going to keep pieces as y. 51,300 pieces should take, well, it takes her about 125. Oh, well, we have k, and I don't know what x is, but I know that k is 125. So I have that. So we're dividing both sides by a 125. I'm not even going to write that in. I'm just going to divide by 125. It's very common to just, everyone knows that we're dividing by 125. And that's very common for someone just to write it like this and say, okay, so that actually means that 410.4 equals x. In other words, it should take Jane 410.4 hours to solve the puzzle. Let's see, 410.4, if I divide that by 24, I can figure out how many days. That is 17.1 days. Straight, that's without a break. So that's a lot of time. Okay, you can, I would accept basically any of this as the answer. Oops, I don't want that to turn, oh gosh. This is just again. And we got the answer. Okay. Moving on. I want that to be black though. All right. We're on the final little bit. We're on the last, this will go faster for the pages. It looks like we're almost 3/4 of the way or half of the way, but actually it's a lot faster from here on out. Each problem takes up a lot of space. So we're doing some graphs and we have to keep track of the constant rate of change, which means it's a straight line. We have to keep track of where it crosses one of the axes. In this case, the y-axis, it crosses the y-axis at -3. Those are the two things I have to keep track of. So first thing I'm going to do is find where it crosses the y-axis, -3. That means that y, it counts up by ones, 1, 2, 3, 4, 5 this way. It counts down by ones this way, 1, 2, 3. If nothing's marked, I just assume it's counting by ones. So 1, 2, 3. This is -3 on the y-axis. That's the y-intercept. So now I know my line, it's going to go through there. Oops, that's not very good. It could be really, it could go up, could go down, it could go steep. It's going to go through that point every time. All right? So that's our first thing that we know. The next thing we're going to do is figure out how steep it is. What I was just saying might happen. So we got to make sure that it has a constant rate of 2. 2 is positive, which means it's going to go up as it goes to the right. And specifically, remember, whenever we talk about slope, we're talking about y over x. This is the rate of change. Okay, it's how much it changes on y. That's what this triangle means. Compared to how much it changes on x. That's what this triangle means. So y, well, let's see, 2 means 2 over 1. That's 2, which means it's going to go 2 up for every 1 that it goes to the right. So the number 2 means 2 up for every 1 it goes to the right. So that's what I'm going to do. This one's pink, by the way. So I'm going to go 1 to the right, 2 up. 1 to the right, 2 up. 1 to the right, 2 up. And there we go. Now I can see which direction the line's going and then turn it black. And I'll make it 2 in thickness, which should be a little bit better for keeping everything in a row. And there we go. There's our line. It crosses at -3 and goes 2 up for every 1 it goes over. And there you go. That's how we graph this one. Notice pink is the rate of change, green is this. You don't have to do that, but I hope that it makes it clear what I'm talking about with each one. So here we're going to do the same thing. First, I'm going to find my y-intercept at 5, or well, that's not a y-intercept, that's an x-intercept. Well, that means I have to look at the x-axis. I have to find 5 on the x-axis. Remember, it counts negative to the left and positive to the right. So here's 1, 2, 3, 4, 5. That's 5 on the x-axis. The next thing I have to do is get a rate of change of -2/3. -2/3. Constant rate of change of negative. Straight line again. I'm not going to make you graph many curved lines, at least not specifically. Like, oh, here's where it goes or something like that. Just want you to know when something is not constant rate. It's curved. All right, so remember, -2/3 is how much it changes on y. Oops. Y compared to how much it changes on x. In other words, it's going to go down 2 and over 3. Okay, down 2 and over 3. That's what it's saying. So down 2, 1, 2, and over 1, 2, 3. All right, there's where it needs to be. I'll make that slightly bigger so we can see it better. Boom. Now, if I'm going down 2 and over 3, if I go backwards, I have to go backwards and up. Backwards 3 and backwards 2. So it's still going down 2 and over 3. But we're asking ourselves, where did it start if it ends up here? Well, it went down 2 and over 3 from here. Down 2 and over 3 from here. Down 2 and over 3 from here. So it is weird at times. If you're going backward, you're actually going up 2 and backwards 3. Just remember that. All right. So here's our line. There we go. There's our line. And now we want to really quickly remind ourselves this is our 5, where it crosses the x-axis. Where it crosses the x-axis is called the x-intercept. It crosses at 5. And this is down 2 and over 3. All right. That pattern will get you anywhere in this. That's all there is to it. The next one has this rate of change of 0 and a y-intercept of 4. Let's find our y-intercept. That's right here. 1, 2, 3, 4. Boom. And constant rate of change of 0 means, well, this would mean positive rate of change. That would mean negative rate of change. In between positive and negative is 0 rate of change, meaning it's not going up or down. This line will not go up or down. I'm just going to draw the line in pink because, honestly, that's our rate of change. Our rate of change is nothing. The line goes straight from side to side. All right. So I can't really make a, oh, and it moves down this much and over this much. No, because it's just not going up or down at all. So no matter how far it goes right or left, it doesn't go up or down, period. That's what a rate of change of 0 means. But it does cross at 4. All right, which is 4 up. Now we got something continuously increasing. Now notice it does not say a constant rate. It means the rate itself is actually getting more. That means that it's getting steeper. Okay, because if you remember, like when we were talking about the speed of the skateboard or whatever else, the steeper it is, the faster they're going. So what we're saying is they're continuously getting faster. So we start out not going fast at all, and then we get faster and faster and faster and faster and faster. The line keeps getting steeper. It's not a straight line because the whole point, straight lines have a constant rate of change. This one doesn't. Rate of change, the steepness of the line is getting steeper continuously. Getting steeper, increasing continuously, always getting steeper. Okay? Whereas this one says it gradually decreases. So we're starting out steep, we're getting less steep until it changes to a negative rate. Negative means instead of going up, we're going down. And bada bing, bada boom, there we are, going down. It doesn't say anything about continuing to get steeper after it's negative. You can do all sorts of things with the other end. But the point is, this gradually decreases during this section. It gets less and less steep until it eventually changes to a negative rate. Negative meaning the line is now going down. All right, now we're going to notice this is a fake graph. I have no idea about this wildlife population. It's just random. Who keeps track of bears, dolphins, and whales on the same graph? I don't know. There's not many places in the world where all of those coexist at the same time, but that's okay. And apparently there are no dolphins by the end, but we'll get to there in a moment. It's saying, on average, what is the rate of change in the number of dolphins from 2017 to 2022? Let's figure that out. Now, if you look at dolphins, that's the orange one. It starts out with 150 dolphins or so. 150. Whatever. 150. Okay. And it goes down steeply. And then as time goes by, they lose fewer and fewer, but they've all already lost so many that there are 0 left at the end. Okay. So this is a curved line. But from 2017 to 2022, they lose all 150 dolphins in this particular place. Okay, so what does that mean? Well, if they're asking for average, and we are asking for average, that means I want to know just if it were a straight line, how steep is that? How many are they losing each year? Well, it changes every year, right? They lose like what? Like 70 or so the first year. And then they lose less than that, and then they lose less than that. Each year they lose fewer, but and that's what makes the line curve. But if they lost the same amount every year, that would be an average. So we're looking for what's that average. So I want to figure out if they lose 150 dolphins over the course of 5 years, how many is that? They lose 150 in 5 years. That's the average that we're looking for. So how much do they have to lose each year in order to lose 150 in 5 years? Remember, rate of change is always how much y changes divided by how much x changes. Remember, this little triangle is delta. It's just a fancy science thing for how much something changes. Okay, so we've got this, x and y, great. Okay, so we just said y, the y-axis up and down, goes down by 150. And x changes up 5 years. So they lose 150 dolphins in 5 years. Okay, well that makes negative 30 if I divide it out. So what does that mean? they lose an average of 30 dolphins each year. Okay, so that's what's going on. Let's see if that makes sense. Well, if I go for the first year, 2018 here, in 2018, we have about 120. We lose 30 here, 30 in 1 year. And then the next year, we drop from 120 down to about 90. That's 30 more. So each year, on average, they're losing 30. In real life, they're losing a lot more than 30 the first year. But when we average it out over the course of the whole 5 years, they lose about 30 each year. And that is what we're talking about. Okay, moving on to the next one. I'll do the next one a little faster. Oops. Redo. Oh, well, I just made a mistake. I was in a hurry. Okay, 30. They lose an average of 30 dolphins each year. Okay, back to the thing. I was erasing this the wrong way, so let me erase it the correct way, and we'll go do the next one. There's only 2 average ones in this particular problem. So on average, what is the rate of change in population of dolphins from 2017 to 2019? 19. Wow, that's a cool way to say it. So where's that? This is right from here to here, 2017 to 19. That is a lot steeper of a line than this one was, isn't it? Which means from 2017 to 19, they probably lost a lot more on average than the second half of the other 3 years. And that makes sense. Okay, so during these 2 years, we're going to say it goes from 150 down to 30, which is down 120 dolphins. They lost 120 dolphins of their 150 in the first 2 years, which makes sense because the line's really steep. Okay, so, now we just got to figure out how much per year. Now notice they really lost more the first year than the second year, but that's not what we care about. We just care about on average. So we can see that this is about here, like that. They lose about half of them the first year and half of them the second year. That's the idea. Okay, so what? It's 2 years and 120 that we lost. So let's use those 2 numbers like we did before. Minus 120. They lost 120 in 2 years, which is actually minus 60. All right, so what does that mean? They lost 60 dolphins each year, well, on average. Each year during 4 years. Okay, that's good. That's the answer for this one. So you can see during this line, this is a lot steeper. If you're just counting the first 2 years, they lost about 60, twice as many per month as they did before. And that's because, yeah, they lost most of their dolphins during the first 2 years. If I ignore that and I say, well, no, I only care about how much they lost over the course of 5 years, I don't notice that they lost most of them during the first half, and then most of them, they didn't lose very many during the second half comparatively. All right, so that's cool. All right, that's it for finding averages. Hope that makes sense. All I did was connect the 2 things that I want to find the average rate of change and find the slope. During what year did the population of whales grow fastest? What is the rate of growth? Okay, so let's take a look at our whales. That's the purple one. Clearly, this is the fastest one. This is where steepest, they grow from about 50 up to 100 in 1 year. So we can just say the whales grew by 50 in 1 year during the 2018-2019 year. Which would be 2018. You could also just write 2018. Talking about time is actually weird for us. It's a very Western thing. Okay, during the next 2 years did the population of bears grow slowest? What is the rate of growth? Okay, now we're going to talk about bears. Where did they grow the slowest? Well, what I'm going to look for is I'm going to look for a place where the line for bears is not very steep. Okay, because it could be changing up or down, but steepness is what makes something change fast. When we're talking about a steep line, that means something is changing fast. Whether it's how many bears there are in this case, or how fast you're growing in height, or whatever else. Steep means fast. So I'll notice this is steeper. These lines right here, from here to here, that is the least steep part for the bears. And it goes from about 90 over here to about 140 over here. Okay, so in 2 years, it goes up by about 50, doesn't it? Okay, so it goes up 50 in 2 years. That means 50 goes up in 2 years. That's 25. We can say the bear population grew by an average of 25 bears each year from 2019 to 2021. Oops. And there we go. Explain what's happening with each population. Let's see. What are we looking for here? Well, the bears population is growing pretty steadily, isn't it? It slows down a little bit in 2019 and then speeds back up at 2021, but it's just steadily growing from about 10 to about 180 or 85. I don't know. You can guess numbers like that if they're not very clear. So let's go with some information. The bear population grows consistently and steadily. It slows a little in 2019 and 2021, and then speeds up again. Wait, 2018 and 2019, I think. 2019 and 2020, and then it speeds up again in 2021 until 2022. All right, sorry. 2019 and 2020. That's a good thing. If you wrote it in your own words, it's probably going to be slightly different, but that's okay. Okay, how about the next one? Let's talk about the dolphin population. The dolphin population drops really fast in 20 and then slows down as it approaches 2022. The dolphin population drops super fast during the first couple years, slowing down as we approach 0 dolphins in 2022. All right, that's the dolphin population. And finally, oh, it's not going to fit. Oh, well, I'll change it to 10. There, that should fit almost. Ugh. Okay, we'll figure it out. I'll put it over here or something. The last one, whale population. Whale population. Overall, it doesn't really change. It starts at about 80 and it ends at about 80. It drops during the first year and grows and drops and grows, but it basically stays about the same, hovers around 80 the entire time. Alternates between positive and negative rate of growth, hovering around 80. There, that'll work, right? This is like that 12 as well, I guess, or 11 or whatever that is. There. Now they all look about the same. Okay, so those are the things I would write. Now let's do this. We're going to figure this guy out. Okay, what's the going up by? This is, we're going to consider the table. We're going to fill out what's missing. So a good thing to do is to always check to see what things are growing by. Notice the left side grows by 1. 1, 1, 1, 1. Easy. The right side grows by 6. 6? Nope. 8. 10. Well, what is that pattern? Can I see a pattern there? I hope you do, because if you can't, then you're going to be in trouble. I noticed that 6 is 2 less than 8, and that's 2 less than 10. So the next number should actually be 12, shouldn't it? So 25 plus 12, well, this number right here, should be, let's see, I'm going to do a little erasing to make space for my writing here. Should be 10 plus 12, or 29 plus 12 is 31. I'll type that in big font so you can see it. Okay, so I know that it's 31 because this should go up by 12. So that's what's been going on with all the other ones. Notice this, if I take a look at them, these are all 2 apart. 2, 2, 2. If you remember from what we did earlier, that means that this is quadratic. If the second difference for y is always 2. You know what? I'll just do a comment and it sounds much better. Okay, let's look at the next one. What are these? Oh, look, the left side's going up by 1s. Look at that. 1, 1, 1, 1. This one's going down by 2. Down by 1. Down by something. Up by 1. I don't even know. Down by 0.5. I don't know. There's a problem here. Something doesn't seem right. Well, let's see if we can find another pattern. Remember, Our choices are linear. This is not linear because if these were the same, so should these be. That would be linear. It's not quadratic because this goes down by 1, and it goes down by 0.5 or 0.25 or something. It can't stay the same. It can't go down by a consistent amount each time. So that won't work. It's not exponential because that would mean that I would get the same number twice or something. I'd get the same types of numbers there. That's not working. So maybe it's inverse variation. If you remember, inverse variation says 2 times 6 has to be the same as 3 times 4. X times y has to always be the same number. Does that work? Indeed, it does. So we notice that in here, x times y will always equal 12. 2 times 6 makes 12, 3 times 4 makes 12, 4 times 3 makes 12, 6 times 2 makes 12. The question is, what times 5 makes 12? Ugh, how am I going to figure that out? I can use a calculator. I can divide 12 by 5 and figure it out. 12 divided by 5 is 2.4. Hey, that makes sense, doesn't it? 2, oops, I'll type it in. 2.4. All right, and this is called inverse variation. X times y is always, all right, almost there, almost there, almost there. This one right here, these are still going up by the same amount. 1, 1, 1, 1. I'm being very nice that way in this test. This one goes down by 100. Then I don't know what. But then it goes down by 12.5. Well, these numbers look familiar. 100 right there and 12.5 is right there. I bet this one goes down by 25. I bet this one goes down by, well, whatever's in here. What does it go down by? Well, 100 is half of 200. 50 is half of 100. 25 is half of 50. 12.5. So it must be going down 50 to get to 50. The pattern is it's always 1/2 of the previous number, which we've learned is called exponential. So exponential, because each number is 0.5 times the previous number. There we go. So simple, right? And the last one, well, this is the last one. It's probably going to be linear because it's the only one we haven't used. Let's see though. 1, 1, 1. These are going to by ones. That makes sense. How about these ones? This is going down by 20. These are going down by 20. Oops, I never had you fill out a number in this one, but oh well, life goes on. Down by 20. Oh, look at that. These are always the same. Those are always the same. Linear. This is linear. It has a slope. Remember, slope is always y over x. Slope of -20 over 1. Or just -12. There we go. We just did the test, my friends. Congratulations. You're going to be great. Do your best. I know you can do this. All right, I'm going to stop sharing.